Hello everyone. This is Team 8. We have worked on the project Exploring Malware Libraries, a comparative analysis of different tools and techniques. We are a group of 4. What is malware? A malware is basically a malicious software which is infected into system or a network. So why is it a problem? It causes many losses. Example, uh, sensitive data might get leaked, um, or files can get corrupted, etc. Types of malware and the characteristics. So there are different types of malwares like viruses, trojans, ransomware, and spywares. Viruses are the software programs that replicate themselves and causes harm to local files. Trojan is is a piece of code which is hidden inside a legitimate code which cannot be detected by a user. Ransomware is nothing but uh, attacker will encrypt all our files and demands some amount of ransom to give us a decryption key. Spyware is a malware that is attacked to steal sensitive information of the user. So why malware is important is that it helps for security professionals in detecting, preventing, and mitigating the effects that are being caused by malwares in various organizations. So there are basically four main types of analysis methods for malware. Those are static, dynamic, behavioral, and heuristic. In static analysis, we will just examine the code. We won't be executing it. We will examine the code, and we will be knowing the structure of malware that has been used. In dynamic and behavioral analysis, we'll be executing uh, uh, tools. In tools, we'll be executing the code to detect the malware. In dynamic analysis, we need a specific environment for the tools to get executed. In behavioral analysis, we can directly execute it on the system. In heuristic analysis, it involves analyzing the characteristics of malware, so that we can identify threats that can be caused using the malware. So these are some tools that can be used to detect malware. Those those tools are from all the above analysis. So what are the steps that are involved in malware analysis? First, we need to identify what type of malware it is. Is that a Trojan or a virus or a ransomware, etc. Then we must gather some information about the malware, like the characteristics and functionalities of the malware. Then we need to conduct all the analysis mentioned above, the static, dynamic, behavioral, and heuristic. Then we have to consolidate the findings. We need to compare each and every analysis, each and every tools, and we need to validate the result and make a report of it.
Hi everyone. Validation for the results obtained from the malware analysis is critical for ensuring that finding the accurate or reliable. Because without validation for the results obtained from the malware analysis, it leads to the misleading and inaccurate and incomplete. So that like here, validation method plays a crucial role in the malware analysis. So we came with four methods. There are one is cross validation, second one is manual verification, third one is peer review, fourth one is testing in real world scenario. The cross validation. In cross validation involves multiple tools and techniques that to validate the results obtained from the malware analysis. It approaches that to reduce the errors and errors. The manual verification. Manual verification here, the checking results obtained from the malware analysis against actual behavior of the malware. These methods help you to identify the false positive and false negative. Peer review. Peer review involves here experts will come in the field to test the results obtained from the malware analysis. This method helps to ensure that analysis uh, obtained from the results malware analysis to helps to its I mean correct and accurate. Testing in real world scenario. Testing malware is real time world scenario involves setting a controlled environment and to simulate the behavior of the malware in the real world scenario. These methods helps you to validate the results of malware analysis by testing and malware's behavior under conditions. So these are validation methods.
So here comes with the limitations, where we have some of the limitations for the malwares, where these are there are different kinds of limitations. For those are polymorphic malware, encrypted malware, zero day attacks, false positives, and cost and expertise. Where polymorphic malware comes with the behavior, avoid detections, and the analysis by the malware tools. So it automatically changes its code whenever we find to check about the malware's functions. And where comes the encrypted one, malware is the code completely hide. It is difficult to find the code and analyze this in which way the malware is functioning. Where from the other one is zero day attacks, it is like vulnerable is attacked to the unknown functions to the in the systems. Basically we'll find a little where we little changes in the system, but those attacks are major. Where other comes to the false positives, it basically it gives a false alerts to us by showing that there is a malware in another functions, where we go to check in that, but generally the malware is not present over there. It the malware is basically attacked somewhere else and shows the alerts in the somewhere else. And whereas the cost and expertise goes with the uh, because the some malwares are not detected by someone, some machines or some tools. So it requires the power of man to directly detect the malware and technically test it. And some tools are not used for checking the high malwares or different malwares. So different tools are so expensive for that. These are the limitations happens in the malware.
In the result, the static analysis, we have examined the characteristics of malware without executing it. It focuses on inspecting the code, file structure, and metadata for malware sample. The results of static analysis include the identification of packers, compilers, or techniques used in a malware, and extraction of strings, URLs, or IP addresses. And it also included the detection of suspicious or malicious functions, API call, or system interactions. And it also, like, we have used it to compare the sample with known malware for the signatures and indicators. And for the dynamic analysis, we have run the malware in a controlled environment called a virtual machine or a SAN mission to observe the behavior and interactions with the system. The results of the dynamic analysis include monitoring system calls, file system modification, registry changes, and network traffic generated by the malware. And we have used the identification communication with the other servers and malicious entities. And we have used we have also captured the network traffic, including the URLs, protocols, and the payloads exchanged by the malware. And for the results of behavior analysis, we focused on understanding the overall behavior and impact of the malware on the system. It combines the elements of both the static and dynamic analysis to identify the actions and the consequences of the malware. And the results of malware analysis include the documentation of malware actions such as file creation, modification, and deletion, and the analysis of malware interaction with the other processes, and the process injection, key logging, and the key capturing. All these were recorded under the behavior analysis results. When considered to the heuristic analysis, we have predefined rules or patterns to identify a potentially malicious behavior or characteristics in the malware. The results of heuristic analysis include the generation of alerts or warnings on a patterns on a signature of known malicious behavior, recognition of anomalous system behavior such as unauthorized access attempts or unauthorized modification of critical files. We also like identified the malware potential impact on the based on the like behavior and characteristics, and we have also used it to the classify the malware into predefined characteristics or family based on its attributes and the similarities to known threats. We have used many tools. Some of the tools we have used in the analysis is like the hash calc. Yeah, hash calc is used to calculate and verify the file hashes. It used to determine the cryptographic hash value of the file, such as MD5, SHA1, SHA256. Or often we use the hash values often to check the integrity of files and capture them so that we could find the malicious samples. Here we can see the we have used this hash value and we have checked in the browser to get this result. And another tool we have used is a PID, which is a process explorer identifier, is used to analyze the portable executable file format, which is commonly for a Windows executable file. It can identify the packer or a compiler used to create the executable, which provides insights into the potential behavior and origin of the file. And the strings is used to determine the strings, the commonly an indicator which will be used by the many hackers and the who can hack the system. And one of the other tool, one of the like automation tool which is used by the malware analysis is Hydra. Hydra is a tool, code analysis, code automation tool, which is used to determine analyze the code very deeply, and it allows in-depth analysis of binary files, including malware. Hydra also provides a wide range of features such as assembler, compiler, and a scriptable analysis to add in understanding the code and behavior of the malware. And the process monitor is a tool for exploring and analyzing the process explorer file. It provides a graphical interface to inspect the internal structure of the executable file, including headers, sections, imports, and exports. And PE Explorer can help the identify the suspicious or malicious artifacts within a executable. And the other important network traffic generator we have used is a Wireshark. Wireshark is a network protocol analyzer that captures and analyzes a network traffic. It can identify a network-based behavior of a malware, such as communication, and with which is based on command and control server data exploration and exploration. Wireshark allows you to inspect the individual network packets and analyze the various protocols. And the other tool we have used is a Regshot, and the Regshot it is a specific tool for the like the to generate the what is the registries that the system is using before and after the malware analysis. This is a very good tool to compare the what are the registry that are installed by the malware and that were deleted by the malware. And the other tool we have used is hybrid analysis, is an like all online malware analysis platform that combines static dynamic analysis technique. It allows you to submit the files and URLs for the analysis and provide detailed reports on the observed behavior and the network activity and provide malicious actions. Hybrid analysis can be useful for understanding the behavior of malware in a controlled environment. And the other tool we have used is a Virus Total, which is also an online service tool that analyzes the files and URLs for a potential malware. It scans the submitted files and URLs with a multiple antivirus engines and provides a detailed reports on the detection results. The Virus Total can help identify known malware and gather additional information about the file, such as behavior, indicator, or relationship to the other sample. Finally, we could conclude that this malware analysis is very helpful, informative to understanding the malware nature, behavior, and potential risk. It serves as a basic for formulating a response plan, and implementing appropriate security measures and preventing the future infections or similar threats. Thank you.